Okay, example number 5. So you have an elevator, 200 kilograms, and the cable snaps, just what you always were hoping for. And when it does, it's initially going 4 meters per second. Clearly the people who built the elevator were worried about this, so they put this big, huge spring down at the bottom, so that when the elevator hits it, it's going to compress it and slow the elevator down. So then really, after it compresses it, it'll go flying back up into the air. But that's another problem for another day. So for right now, we're looking at how far does the spring get compressed by the time the elevator stops. So somewhere down here, whoops, sorry, it's hard to do that when the recording device is right in front of me. So somewhere down here, the spring's going to compress, so this is going to be X, how much it compresses. Where the elevator is above the spring when we start is 6 meters. And so really, this question's going to have all 3 types of energy. You just have to be smart about where you pick your initial and your final. I think you should pick your initial up here, where the speed is 4 meters per second and where it has a height. The thing is, the height won't just be 6 meters, perhaps, because I would suggest you pick your final when it's down here, when the spring has been compressed and the elevator is stopped, so that your VF is 0. And actually, at that same point, your HF will be 0. Okay? What it means, though, is that your HI will be 6 meters plus X. Okay? It can't just be 6 meters. If it's 6 meters, then you're picking your 0 point here in the middle. And if you do that, then you don't know what the speed is at that point, and life gets complicated. Okay? So let's pick our initial up here. Let's pick our final down here. If we do that, then initially it has a speed, yes. Initially it has a height, yes. When it's up here at the top, there's a spring there, but it's not stretched or compressed yet. It hasn't touched it yet, so this goes to 0. If we do our final all the way down here at the bottom, then when it gets there, the elevator has stopped, and there is no height. But the spring is definitely compressed, and there's no E lost on this one, because I figured I gave you enough other types. So it leaves us with 1/2 mv initial squared plus mghi, but the hi is really 6 meters plus x. And that's going to equal 1/2 kx final squared. The reason these guys are a little tougher is you're going to end up with a quadratic, right? You're going to have a 1/2 mvi squared, which you know everything, that'll be part of your C term. Multiplying through the brackets, you're going to have mg times 6 meters. That'll be your whole number term as well. Plus mgx, that's going to be your middle term, right? Ax squared plus bx, this will be your bx, is equal to 1/2 kx final squared. This is your ax term. Okay, so that's what's going to make this complicated, is we're going to have to use the quadratic. Perhaps fill your numbers in before you rearrange. You'll be able to see it a little easier. So 1/2, 200 kilograms. The speed at the top, I think, was 4 meters per second. I've used 200 kilograms and 4 meters per second in an awful lot of these questions. Did you notice that? 200 kilograms times 9.81 meters per second squared times 6 meters, plus 200 kilograms 9.81 meters per second squared times x, and that's going to be equal to 1/2 8,500 newtons per meter x squared. Okay, so first term, actually before I even do that, look, all the terms have, you can divide by 100 and get rid of all those zeros, so you're not dealing with really big numbers. So get rid of the zeros on the 200, the zeros on the 85. So the first term then just becomes 1/2 of 2 times 4 squared, 16 kilogram meter squared per second squared. That's going to be a Newton meter, that's a joule, plus 2 times 9.81 times 6. That's 12 times 9.81. That should be 117.72, I think. Again, joules. Plus, sorry, I know this is at an angle, but it's because of the way I'm writing around the iPad that I'm videotaping this. Alright, next term is going to be 100 times, the 100's gone, 2 times 9.81, so that's going to be 19.62, and kilogram meters per second squared, that's a Newton, and that's times x. And then over here on this side, 100's gone, half of 85 is 42.5, and that's newtons per meter, and that's x squared. So now you can take all of your terms to the same side. And I would suggest you bring them all over to the right so your x squared term is positive. Okay, so take these guys over there. And so it'll become, on this side you'll be left with 0, and it'll be 42.5 newtons per meter, x squared. This term, when I take it over, will become a minus 19.62 newtons, and that's times x. And then these two, when I put them together, 133.72, and when I take them over, so they're going over, so when I take them over, it becomes negative 133.72 joules. Okay, and so now I have my quadratic, and it's in ax squared, bx, and c form. And I think you've been doing the quadratic perhaps now in math, so this shouldn't seem as weird and scary. So we're going to use the quadratic formula, and if you remember, it's x is equal to negative b plus or minus root b squared minus 4ac, all divided by 2a. Okay? And so we get, whoops, off the page, x is equal to negative b. Well, my b is negative 19.62, so negative, so positive. 19.62 newtons, do not lose your units. Plus or minus square root negative 19.62 newtons squared minus 4a is 42.5 newtons per meter. C was negative 133.72 joules. And all of that gets divided by 2a, so 2 times 42.5 newtons per meter. Okay, and so we have x is equal to 19.62 newtons plus or minus. When you square 19.62, I think you get 384.9, maybe 444, and that'll be newtons squared per meter squared. No, sorry, there was no meters in there, just newton squared. The negative and negative become positive. And then when I multiply these three terms together, I get 22732.4. And a newton per meter times a joule. Remember, a joule is a newton meter, so that'll cancel. And this will also give me newton squared, which is a good thing, because it means I can now add those two terms together. And on the bottom, I will have 85 newtons per meter. So I have x is equal to 19.62 newtons plus or minus. The whole thing under the root becomes 23117.3444, whoops, off the page, newton squared over 85 newtons per meter. So now I take the square root, and I get 19.62 newtons plus over 85 newtons per meter, and I will also get 19.62 newtons minus over 85 newtons per meter. So I'm going to take the square root, and I'm going to get my two possible terms. So when I take the square root of that 23,000, Square root is 152.04